We're going to take a look now how we can use the vector state node to modulate a gradient that shades a particle cloud. So basically what we want to do is use the vector state node to extract the particle position, convert that position to global space, and then compare that global space to another global reference, say the origin. So based on that particle's position from the origin, we can modulate the gradient. So in this case, if we look at this cloud here, what we want to do is create a nebula type effect. So at the origin, which is 0, 0, 0, we want to control, create sort of a red hot look, and then basically fade the gradient off to various colors as we reach the outer borders. So first thing we want to do is just go over to our part type. By default, we just have a billboard and a shape node plugged in. What we want to do is extract the particle position. So we'll use the vector state node. And in there, the state parameter we want to use is the intersection point, which will essentially give us the particle position. And next, what we want to do is convert that particle position from local to global space. So we need to use a converter, a vector coordinate converter. So from here, we're going to go from a local coordinate system to a global coordinate system. So we want to use a point type, and the transform is to world space. So now we're in world space. We want to compare that position to the global world space origin. So for that, what we want is a vector scalar node. So by plugging this into vector input 1, what we can do is leave vector input 2 at 0, 0. So this basically represents the global origin. And what we want to do is get the distance between vector 1 and vector 2. So now we have that distance. It'll convert it to a scalar output now that we can use to drive the gradient. So we simply get particle gradient. And by default, when we use the particle gradient, its evaluation criteria is based on age percentage. So if we look at it, at the beginning of the gradient, this is shading the particle at 0 age percentage, and then this is at 100 age percentage. So I'm just going to go in here and delete some of these guys. Let's just set this up quickly. We'll leave it like this for now. So what we want to do is output that scalar into the particle gradient as the evaluation point. So now it's saying use that scalar value to modulate the gradient rather than age percentage. So let me just clean this up a little bit. And there we go. That's the effect we're getting right now. By default, the evaluation range is set from 0 to 1, so representing the life of the particle. We need to sort of calibrate that so the scalar value is being considered fully. So I can bring that up a little bit. And we'll need to change frames to force the particle to reevaluate. And there you can see we're actually considering the full scalar range there. So I think about 15. 15 is about right. There we go. Now we just need to set the actual color value. So at the center, we'll just make it this kind of red hot value. You can add some markers in here and slowly ramp it in. Let's make this like a blue value. Let's change frames here. Way from the origin, we're slowly shading the particle using the gradient. We can go to the alpha and modulate that as well, however we want. And you definitely, I guess you can get the idea. Each of these markers can actually be driven by a texture, so you can go in and use some procedurals or different effects to modulate the effect and get something a bit more realistic. But that's essentially how to use the vector state node as to control your particle gradient.